So here we shall look at some of the problems based on polar integration. How could you solve various problems according to this polar integration? Suppose the first question, if we take this first question, so the question 1 is change the Cartesian integral integration from 0 to 6 and integration from 0 to y x dx dy into the equivalent polar integral. So how do you do that? How do you shift or convert one Cartesian integral into the equivalent polar integral? So for that, the first condition is always to visualize the region. So here, what is your region? Here you see your limits. These are the limits of x and these are the limits of y. So according to this, your area of integration, what is this? This is all the points x, y such that the limits of x, they are from 0 to y and the limits of y, they are from 0 to 6. This is given to you. From here, you can draw the area. What could be your area? So from here you have x is equal to 0 according to this, and according to this you have x is equal to y, and from here you have y is equal to 0 and y is equal to 6. So that means you have these 4 lines. So we can very easily draw these straight lines. So this is your x-axis, this is y-axis. So x is equal to 0 is this y-axis only, right? And y is equal to 0 is this x-axis only. Y is equal to 6. Suppose this point is 0, 6. So y is equal to 6 would be a line parallel to this x-axis passing through this. So this is your y is equal to 6, and x is equal to y would be a line passing through the origin and making an angle of 45 degrees with the given initial line, that is x-axis. So this is the line x is equal to y. Now, what is your shaded region or the area in which you are interested? The area would be bounded by all these 4 lines. So our area here would be this particular area. So here you have to convert your Cartesian coordinate into the corresponding polar coordinate. So for that, you first note that what is this point? This point over here, whenever x is equal to y and the value of y here is equal to 6, so this point is 6, 6. So this point is 0, 6, this point is 0, 0, this point is 6, 6. So now we have to convert our given integration. So we have to convert this 0 to 6, x varying from 0 to y, this y varying from 0 to 6 of the function x dx dy into the corresponding polar form. So that means whenever you convert it into the polar form, you will write in place of dx dy as r dr d theta, and in place of x, what will you write? You will write the value of x is equal to r cos theta. So you will write this value here. So this is equal to r cos theta, and here you will write whatever the limits of r, and here you will write whatever are the limits of theta. Okay, so for that we have to determine the limits of theta. So now let us see what are the limits of this r and theta. Now what you did previously, so you just draw a ray within this shaded portion. So that means you will draw this ray, say this is some ray L. So now you have to see for this ray what are the limits variable for r, because here if you move on to this, here the value of r would be something else, here the value of r would be something else, because what is r? R is this particular distance. So whenever you move on this line, this distance keep on changing. So that means here what is changing? The variable r is changing over here, right? And for this particular ray, the angle theta would be constant. So in this case the variable would be r. And what is the value of r here? So the minimum value of r that enters the area is this point, and this ray leaves the shaded portion here at this point. So you will have to determine what is the value of r here and what is the value of r here. So this value would be your upper limit of r, and this value would be the lower limit of r. Now you have to determine what is the value of r here. You know, at the point 0, 0, the value of r is equal to 0, because we measure the distance of r from origin, and at origin the distance would be 0, so your lower limit is going to be 0. And for the upper limit you have to determine what is this particular distance, what is this whole distance, right? So for that you can use trigonometry. If this angle is theta, then according to, because these two lines are parallel, then according to alternative angles, this angle is also theta, right? And because this line makes an angle 90 degrees, so we have a right angle triangle at this point, the origin A and say this point B, right? So we have right angle triangle. Now we have to determine what is this length, what is the length of this hypotenuse over here. So for that, you know, this distance is given to be 6, because you know this point is 0, 6. So according to trigonometry, what would be the value of r here? So if you see here, you wanted to have the value of hypotenuse, so hypotenuse upon perpendicular here is equal to cosecant theta. So from here you can obtain the hypotenuse, that is r, that is equal to 6 cosecant theta. So that is how you obtain this upper limit. So this is equal to 6 cosecant theta. And this is all about the limits of r. These are the variable limits, they depend upon theta. Now coming on to the limits for theta. What are the limits of theta? The limits of theta, they will vary from this particular line to this particular line. So that means you have to see what is your value of theta for this particular line. For this particular line, what is this angle? And for this line, what is this angle? For this first line, this angle is the angle made by this particular line, x is equal to y. And you know, this line makes an angle of 45 degrees with this x-axis. How? You can very easily convert this into the equivalent polar equation, and then you can see what is the angle made by this line. Also from slope, you can calculate the angle, right? Because you know what is theta? Theta is tan inverse y by x. So from there you obtain the value of theta as pi by 4 here. So this is the value of theta here, pi by 4, and the value of theta here would be 90 degree, because you know y-axis makes an angle of 90 degree. So this is pi by 2. So this is how you obtain the limits. So this is how you convert your given Cartesian integral to the corresponding, this was your Cartesian integral to the corresponding polar integral. And now you can very easily solve this integral. So I'm leaving this to you to solve this integral. Let us now discuss next question. So the next question is question 2, that says you have to change into polar coordinates. You have to first change into polar coordinates and then evaluate the given integral. Integration from 0 to infinity, integration from 0 to infinity, e to the power minus x square plus y square dy dx. So you have to solve this integral firstly by converting it into the polar form. So the first step again is to visualize the limits. Now if you see what is the given area. So your given area consists of all the points x and y such that the limits of y, they are from 0 to infinity, and the limits of x, they are from 0 to infinity. So that means your area would be the values of x lying between 0 and infinity, and the values of y also lying between 0 to infinity. And remember, you do not write equality here in this case. Why? Because we cannot exactly say what is the value of infinity. So always this is an open interval. Okay. So here firstly we have to determine our region. So for that we will draw the lines. First line would be this x is equal to 0, y is equal to 0. Another line would be x is equal to infinity, y is equal to infinity. That means your region here is the unbounded region, and this region will go up to infinity. So how would it look like? So this is x-axis, this is y-axis, and your region, this point is origin 0, 0. So it will go up to infinity. So whatever is this whole region, that is your region. And similarly in the upward direction also you will have the same region, right? It will move on to up to infinity. So this is whole is your region. Okay, now we have to convert this region into the corresponding polar equivalent. So you know, for polar equivalent for this region, you have this relationship: x is equal to r cos theta, y is equal to r sin theta, and your dx dy, they are equivalent to r dr d theta, corresponding to the relationship. So now the remaining part is that of limits. So you have to see your area now becomes what all points. So in this case your area would be all the points r theta, such that you have to determine these limits of r as well as theta. Now if you see from here, to determine theta, it is very straightforward. At this arc, what is the value of theta? The value of theta here is equal to 0 degrees. And what is the value of theta here? Because this is your region. So value of theta here is equivalent to 90 degrees. So the limits for theta are very simple and they are constant limits. Now you have to determine the arc for this, the values, variable values for r. So that means you have to draw this arc, say L, into this shaded region. So you have to see at the entry point what is the value of r here, and at the exit point what is the value of r here. Now at the yes. So this is how you can draw the circles. R is equal to 2 cos theta and r is equal to 4 cos theta. Actually, what is the center and what is the radius? That is not so important in the calculation, but you should know what are these centers and radius. So tomorrow you will tell me what are these center and radius and how can you evaluate these for these two particular circles. So these are two circles. Another, in Cartesian coordinates, what you can do, you can convert this into Cartesian coordinates. You know your equation, y square plus x square is equal to r square. So what is your r? R is 2 cos theta. So r square would be 4 cos square theta. So this is one equation. In Cartesian, this is one equation. Another equation is theta is equal to tan inverse y by x. So using these two equations, you can evaluate the value of x and y. This would be very typical, but you will tomorrow tell me what is this, how do you draw these two circles. So in this case, our shaded portion is this particular portion. So now the limits are from 2 cos theta to 4 cos theta, and the limits of theta, they are simply, because this is the whole complete circle, so either you could take the limits from 0 to 2 pi, or you could also take the limits of theta from minus 2 pi 2 to minus pi by 2 to pi by 2. So these are your limits of integration. So accordingly, your integration r cube dr d theta. Now that is converted to this theta varying from minus pi by 2 to pi by 2, and r varies from 2 cos theta to 4 cos theta, r cube dr d theta. Now the thing that is remaining is you have to firstly simplify this whole expression, and then you will simplify with respect to theta, integrate with respect to theta. So we'll keep the components of theta as such, and then we have to perform the integration with respect to r. So it would be r to the power 4 divided by 4, and the limits of r, they vary from 2 cos theta to 4 cos theta. So this would be equivalent to 1 by 4 outside. So this is equivalent to theta varying from minus pi by 2 to pi by 2 of the function 256 cos raised to power 4 theta minus 16 cos to the power 4 theta d theta. So now we can simplify this with respect to theta. You can solve these components. So finally, with respect to theta, your answer would come out to be 45 pi by 2. So this is the final answer.